Good morning, good afternoon, good evening, whatever the time. Assalamu alaikum. Today, on this video, we are going to talk about aromaticity. In Arabic, it's الصفات الأروماتية للمركبات. We know that organic compounds are divided into aliphatic compounds and aromatic compounds. So today we are going to talk about aromatic compounds. So the aromatic compounds got aromaticity, الصفات الأروماتية. So let's go for this aromaticity. In general, benzene is an example of aromatic compound, which is a colorless liquid immiscible and lighter than water and miscible with most organic solvents. Of course, it's immiscible and lighter than water. It's immiscible because it's a non-polar compound, and you know that water is polar. So like dissolves like. So benzene will not be miscible or dissolved even in water, but with organic compounds or organic solvents. Boiling point is 80 centigrade and freezing point is 5.5 Celsius. Benzene is very stable, and we'll discuss that in details during aromaticity. A stable compound in a series of and resist a series of electrophilic reaction. For example, bromation of benzene ring, no reaction in the presence of CCl4. Of course, each point will be discussed in details during the upcoming slides. Okay, let's go. First of all, how we decide the aromatic compounds according to the Hacker rule, which is state that planar monocyclic ring with a continuous system of p orbitals, and following the 4n plus 2 equals the pi electrons are aromatic compounds. So what are aromatic compounds? They got a four important criteria or important points that should be present in the aromatic compounds. Of course, we will discuss Hacker in details, and we will say what is N. It's integer. It's 0, 1, 2, 3. What is that? Okay, let's go first for the 4 points or requirements for an organic compound to be organic compound to get aromaticity. First of all, it should be a planar. It should be in a one plane, like 2D dimension, not 3D dimension, for example. It's 2D dimension, X and Y axis. It should contain sp2 hybridized carbon. يعني نوع التهجين الهybridization is sp2 in carbon atom in this ring. This should be ring. طبعا هنا we have to say it's a should be a planar. It's a ring, planar ring. This planar ring containing carbon atoms. This carbon atom should be sp2 hybridized, and it should follow Obi Hacker rule, which is 4n plus 2, 4n plus 2 equals to the pi electrons, contains a continuous resonance conjugation, and finally we have this example. طيب, I want to make it one by one. First of all, let's go for the first, which is should be planar. As I mentioned, it should be a planar cyclic compound. So we have benzene like that. It's like that. It's in the same plane of your sheet، في نفس مستوى الصفحة. ما فيش مثلا ايه ان هو في extension للخلف وللامام وهكذا، لا، في نفس مستوى الصفحة. This is first of all, and we have it like that, my dear students. So it should be planar. Its cycle should be planar. Then here I have carbon. Here I have carbon. Here I have carbon. Here I have carbon. Carbon, carbon. So for example, for benzene, I have 6 carbon atoms. Each one is sp2 hybridized. طبعا احنا عندنا الهيبريدايزيشن او النظام التهجين في الكربون. It is sp2 and finally sp3. So I will talk about sp2 in general to clarify what we are going to do من باب العلم بالشيء، لان احنا لازم نكون عارفين يعني ايه نوع تهجين وعارفين ما معنى ذلك. The carbon atom, the atomic number is 6. So let's make our configuration. I have the carbon, it is 6. So it will be 1s2, 2s2, 2p2. So carbon atom to perform, for example, bonding, it should perform 4 bonding because I have this energy level. I have the first 2 electrons in the first electron level, and in the second electron level, I have 4 electrons. So to get satisfied, to get stability, you need to share by another 4 electrons. So these 4 electrons will participate by making covalent bonding to get the octet rule, which is the 8 electrons in the final or the outermost shell. So let's go for the configuration of carbon itself. Look at that to talk about exactly about sp2. First of all, let's say this is the energy level. This is the energy. So what we have here, we have one S, I have 2 electrons. Then let's go to the second energy level. I have 2s. I have here 2 electrons, and I have here 2p. We know that p is higher energy than s in the same, so I have it like that. So how many electrons remaining? I have only 2. Why? Because I have 1s2. Thank you very much. 2s2, thank you very much. And finally, 2p2, which are this one. Of course, we know that tx, ty, pz. Now, hybridization takes place in 2 steps. First of all, first step, excitation of 1 electron from 2s to 2p. So I will make it like that. So خلاص, keep the first 1s2 as it is. خلاص. Then here in 1s, okay. Now let's go for 2s. One of these electron will go up, excited to go to the 2p to be like that. 1, 2, 3. خلاص. This electron, خلينا نعمل عليه cycle. This electron was exactly in the 2s. The first step in hybridization is excitation of 1 electron to jump to the higher energy level in the same main energy level. It will jump from 2s to 2p. So now we have 4 electrons, 1 in s and 3 in p. So the next step is merging these two, hybridization of these two, merging of these two subshells to give a hybridized orbitals, which is sp2. How we can do that? You need s. Imagine I have here 1 and p2. It means I will merge 1 electron from s and 2 electrons from p. 2 electron from p. Let me make it with another color. So you have this electron will merge with, hybridize with these 2 electrons. So what is the next? The next is a hybridized orbital with an energy in the middle between the energy level of S and P. So this energy level will be here like that. So let's do the third one, which is the second step. The second step, let's change the color again. The second step طبعا هنا one step. The second step is this is my energy. Of course, I have 1s below as it is 1s2. So what we have here, I have no 2s now. I have, of course, this 1, 2, 1, 2, 3. What we call this one? We call it 2sp2. So I have 1, 2, 3 subshells will merge to perform a new energy level, hybridized energy level containing 3 electrons, hybridized of all of the same energy level, and 1 remaining in the 2p, which will be like that for 1 electron. What is this one, my dear students? It's pz. Yes, it's the remaining. يلا مباشرة واحنا مغمضين. All electrons in sp2 will perform a sigma bonding. So carbon will perform 3 sigma bonding, and all electrons in the p electron will perform a pi bonding. So immediately, what we are looking for, benzene is like that. C, 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 and C. Look at that one. Double bond, single bond. Double bond with conjugation, single bond. Double bond, and finally single. Now, how many bonding you have? I have 3 for each carbon. The fourth will be for hydrogen. H, 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 and H. Now, carbon performance for bonding. Very good. Each carbon atom is sp2. بيني وبينكم بقى how many sigma bonding؟ اجمعوا الاسس. الاس عليها 1، البي عليها 2، هتعمل 3 بوندنج. المتبقي 3 سيجما، المتبقي من رقم 4 بيعمل باي بوندنج. I told you this electron will perform a bi bonding. These 3 electrons will perform sigma bond. يلا let's check. Let's check. Where are they? Where are they? Huh. This is, for example, I will look for this carbon. Sigma bonding between C and C. Sigma bonding between C and H, and sigma bonding between C and C, and the second one will be a bi bonding. Yes, exactly. Exactly. The benzene ring, each carbon atom containing sp2 hybridization, it performs 3 single bond، واحدة مع C، واحدة مع الاتش، واحدة مع السي الثانية. بس السي الثانية بتعمل دبل بوند. الدبل بوند عبارة عن سيجما وباي. Why باي؟ because I have one electron in the p orbital. طبعا بي زد، يبقى هنا في بي زد وهنا في بي زد. البي زد always perform a bi bonding like that. هنا الكربون وهنا الكربون. This is clear for sp2. This is how to know the hybridization in carbon atom before going through inside. So I will stop this record and continue to the other record to save the size or the volume of that. Okay. بسم الله الرحمن الرحيم.